Hello, my name is Tyson Grenier. The date is 5/26/2022. So in this personalized video, I'm going to do two different case studies. And we're going to talk about them and go over why I chose the answers I did and why I didn't choose the other answers. The first case study I will be doing is case study 2, and then we'll jump to case study 4 to finish out this section of the assignment. The first case study, case number 2, I'll just read just the case study real quick. It says a 16-year-old female is recently diagnosed with a deficiency of muscle glycogen phosphorylase. She and her family are concerned and ask the following questions. Based on what you know about skeletal muscle glycogenolysis and muscle metabolism, please respond to each question with a thoughtful answer that describes the metabolism in these various scenarios in language that your patient will understand. So the first question is, I'm not sure I understand the issue. Can you explain how muscle glycogen is used normally during exercise? So muscle glycogen, it's really amazing. The body, when we eat, takes that fuel and uses it to create glucose within the body. In the fed state, we call it. This causes insulin to be high, causing our bodies to be able to, at least in our skeletal muscle and in our red blood cells, to intake that glucose. When it does this in the muscle, through the glucose, there is excess glucose within the fed state that is not being used for energy. This is diverted to glycogen storage, or basically fuel storage, as the body needs it. So when the body exercises or moves, in a sense, it uses the muscle glycogen phosphorylase to access this fuel source, the glycogen stored within the skeletal muscle, and uses that and converts it into glucose 1-phosphate, which is just a preliminary to glucose that we can use within the cell, within the skeletal muscle, to use it as a fuel source. So that's when we exercise, our bodies use more energy, right? So in doing so, we have to have that storage of glycogen, which means we have to have that enzyme of muscle glycogen phosphorylase to break down the glycogen that we've stored to use it as a fuel source. So basically, your body is unable to take the fuel source that it has and quickly convert it into glucose or sugar, basically, for your body to use when you've used up what's already there. And it can do that at a slow pace, but not as fast as it needs it when it needs it for heavy, intense exercise. So the second question that the patient asks is, I really like to take long walks. Will I still be able to do this with my friends? And the answer is maybe. It depends on how fast you walk and how long these walks are. Basically, you still have some muscle glycogen phosphorylase that is still working, but your body, when you do exercise, tires out more quickly. And basically, you have to be careful when you do intense exercise. So walking, you'll probably be okay, but it depends on how fast you walk and how long you walk. You may need to take more breaks. One thing that can help is, eating a high carbohydrate or high sucrose or glucose rich drink or food before you go and do these exercises or these walks. Also, you have to be careful in doing so because you don't want to cause other health issues at the same time in digesting and eating so much sugar. So walking, you're probably okay with your friends, but you have to listen to your body. It may get tired more quickly. You may need to take more breaks. You may start to experience muscle cramps and muscle fatigue pretty quickly. And so you have to be careful in what your body's telling you and listen to it as you find out what what is best for your body. Question 3 that the patient asks is, as a result of this deficiency, will I need to get up at night to eat to maintain my blood glucose levels? And in the research that I did, and what I found is, no, you don't need to eat during the night to maintain your blood glucose levels. Your body still has a certain amount of muscle glycogen phosphorylase that it is using, and as long as you're not heavily exercising or moving, your body can still maintain its blood glucose levels through glycogenolysis and gluconeogenesis, as well as regular glucose that you ingest before you obviously go to sleep. You just, as long as you're not running marathons in your sleep, I think you'll be okay to not wake up and eat during sleep. The fourth question that she asks is, do I need to worry about producing excess lactate during intense anaerobic exercise? So this question has two answers. One, you have to be careful when doing intense anaerobic exercise with this issue, with this disease, also known as McArdle's disease, which is the deficiency in this muscle glycogen phosphorylase. So in doing anaerobic exercise, usually people can only do them for a few minutes before they become extremely exhausted and extremely tired, and having muscle cramps, muscle pain, and different things like that. And usually what happens is you're unable to produce lactate, because what happens is the body takes that glucose, or the fatty acid synthesis, the fatty acids that it uses, and is unable to turn that into lactate because it's not able to access that glucose or the glycogen in a anaerobic state. So you will actually see a decreased lactate production within your body. So what they suggest is, again, eating those things high in glucose, maintaining creatine levels. Some people say that high levels of creatine in your diet can help, as well as it helps the muscle regroup, bounce back faster, as you will. So anyway, finished with that case study. The second case study is case number 4, and I'll just read the case study very quickly. It says, a previous healthy 2-month-old female presents with jittery spells several hours after breastfeeding. Her mother reports that she has not given the baby anything to eat other than breast milk since birth. The baby has only recently been sleeping for more than 2 hours between feedings, and that's when the mother reports these symptoms started. Laboratory results are consistent with hypoglycemia, but are otherwise unremarkable. Epinephrine is administered, and there is no increase in blood glucose, but there is an increase in blood lactate. Physical exam reveals a liver edge 4 centimeters below the right costal margin. Percussion of the right chest and abdomen confirms hepatomegaly. Blood glucose levels increase after breastfeeding, but she cannot maintain blood glucose levels within a normal range during fasting. Based on the information above, which of the following is the most likely diagnosis of this patient? And the 4 answers are hereditary fructose intolerance, galactosemia, glycogen storage disease or inability to use glycogen, and glucose 6-phosphate dehydrogenase deficiency. So we'll go through each one of these, talk about why it could be or wouldn't be each one of these, and then talk about what I chose and why I chose that. The first one being hereditary fructose intolerance. Well, I believe it's not that. The baby's only been eating breast milk. Breast milk is lactose, which is galactose and glucose in its 2 monosaccharide forms. So she's not even eating fructose as a form of diet. So I know that it's not the first one. Galactosemia, classical galactosemia, as it's also called, could very well be one of the answers, and it's actually the answer I chose it to be as an answer to this question, because of a couple reasons. One, the baby is only ingesting lactose, which is galactose and glucose. 2 is the clinical symptoms that we find in the case study, that there's hepatomegaly, hypoglycemia. Epinephrine doesn't have an effect on increasing the blood glucose, as well as soon as she breastfeeds, she is able to increase her blood glucose, but only for a limited amount of time. This is due to a deficiency in the enzyme GALT, which basically takes galactose 1-phosphate and converts it into a UDP sugar that is then converted into glucose within the body for the baby to use as energy and to maintain blood glucose levels. This deficiency in this enzyme causes a buildup of the galactose 1-phosphate, causing the galactosemia, the buildup in the liver of this of the galactose. This causes lots of clinical symptoms, lots of which we talk about here: the hepatomegaly, the jittery spells. It can cause cataracts to develop. Also, can cause other organs to have issues, which is what we see in this case study example. As well as the baby only being able to maintain her blood sugars for a certain amount of time, because there is not enough GALT enzyme within the body to maintain those blood sugars of the UDP sugars to convert it into glucose within the body. The next answer, and why I believe it is the incorrect answer, is glycogen storage disease, or inability to use glycogen. I believe this is incorrect because all of the baby's glucose that she is getting, she's using to maintain her blood glucose. So she is not storing any glycogen at this time, because she is there's not an excess of glucose in the blood, which is what is stored as excess glucose as glycogen. And if there were, then she would be able to maintain her blood glucose levels for longer than just a couple of hours, which is not what we're seeing. We're seeing hypoglycemia even after just a few hours. The last one is glucose 6-phosphate dehydrogenase deficiency. And the reason I think this one is also incorrect, this glucose 6-phosphate dehydrogenase deficiency is used in the pentose phosphate pathway to create 5-ribose sugars, which is then used for things as production of mRNA, DNA, RNA, things like that. It's not necessarily directly used in the form of blood glucose levels, and doesn't have anything really to do with the case study as it presents. So that is my 2 case studies that I have studied, and I appreciate your time, and we'll see you later. Thank you.